Hi, I'm Jack. This is my mind map for Unit 2. Um, it's probably going to be pretty hard to see on the video, so hopefully you can follow along on the picture that I sent you of it. So I kind of decided to do mine in the shape of the solar system, and then have all of the key terms and ideas revolve around the planets or areas in the solar system where they would be found. I guess I'll start with the center of the the solar system, with the sun. So I have the sun here. I split it up into its different layers. There's the core, the radiative zone, convective zone, the photosphere, and I've noted here that the photosphere is where you can find sunspots. There's the chromosphere, which is the part you can see, and then radiating out from everywhere on the sun is the corona. Some things related to the sun. I have a CME here. I drew it like a lightning bolt because, however, while they're not similar, their destructive powers can be related. I have solar flares over here. I have a small solar flare labeled as a solar minimum and a large one as a solar maximum. This isn't a great depiction of solar minimums and solar maximums, as it's all things that emit from the sun that get pushed to the minimum and maximum, but I thought this was the best way to show that. I also have solar prominence down here. My chair handle's in the way, but it's there. And I have it in swirling loops because that's how it emanates from the sun. Also coming from the sun that goes throughout the whole solar system is solar wind. And I have an arrow here that shows that beyond that is T-Tauri wind. Coming next off from the sun, I have a little orbit here. Kepler's first law. Orbits are round or elliptical. I also have these two symbols here, which kind of shows how radial velocity works. Mercury is the orbit that I'm kind of looking at here. You can see here that the orbit kind of loops out from its regular orbit, and that's what eccentricity is. And then in orbit, I have aphelion, which is when something is the furthest from the sun in orbit, and perihelion, which is when it's the closest to the sun in orbit. I also have a little diagram of an ellipse, and which is Kepler's second law. Coming next is the terrestrial planets, Mercury, Venus, Earth, and Mars. In this area is the Goldilocks, or habitable zone, which you can find Earth in. Even though technically it would be like here and then over here, I have the equinox and equinox at two opposite sides of my diagram, just to kind of show that in real life it's when the sun, or the Earth, is on two opposite sides of the sun. I also have, coming from the sun, is a gravitational field. I didn't know the best way to demonstrate that, as it kind of just exists everywhere all the time, so I just kind of drew a little squiggly. And you can see here where it interacts with the Earth's magnetosphere, you get auras. Around the Earth is a bunch of different satellites and telescopes, and that shows transit method, which is just looking at something from a bunch of different points in space and on Earth, and measuring it by how far it was away that you viewed it from. I have a little diagram here. Meteors are outside of Earth's atmosphere, meteoroids are inside Earth's atmosphere, and meteorites are on Earth. There's the moon. I have the moon in different locations around the Earth, and depending on where it is around the Earth, it reflects different amount of lights from the sun, which are lunar phases. This side of the Goldilocks zone is the frost line, so any water from here on out is frozen, other than stuff closer to the planet's cores, like some of Jupiter's moons have an ice surface but have an ocean underneath. Coming off of Mars, there is, I have a solar eclipse here. Now the moon wouldn't be between Mercury and Venus, but due to the compressing of this diagram, it just shows that a solar eclipse is when the moon is in between the sun and Earth, and a lunar eclipse is when the Earth is in between the sun and the moon, and the light from the sun kind of bends around the Earth and makes the moon red. That's also focus I have there, which is what creates the blood moon. And this squiggly line here is the asteroid belt, in which are asteroids, obviously. Next is the Jovian planets. So you have the gas giants, Jupiter and Saturn. You have the ice giants, Uranus and Neptune. Coming off of Jupiter, I have a couple of moons drawn here, which are satellites. A satellite is any object that orbits a greater mass to a certain extent. I don't think planets are considered satellites, even though they revolve around the sun. But moons and like Pluto is a satellite, I think. And Ceres and the asteroid belt is a satellite, I'm pretty sure. And then just coming off of Jupiter moons, because we covered a couple of times how Jupiter's moons have some of the greatest chances for life in the solar system. I have astrobiology. Coming from is extremophiles, which are extremophiles. Saturn, I just have a little dotted line just to show what kind of the inner planet means. So for Saturn and Jupiter, they have a lot of gas, but in their core it's more condensed and I'm pretty sure probably liquid. I guess next I can cover this little box here. I didn't really know how to include the physics of the universe, or not the universe, well technically the universe, the physics in this diagram, because they're everywhere, they exist everywhere all the time, so I just drew a little box here. You have Newton's universal law of gravitation. Force of gravity equals the gravity constant times the mass of the first object, mass of the second object over the radius squared. Kepler's 3 laws. For Kepler's 3rd law is the law of harmonics. I have the formula there. And then some of the theory that revolves around the creation and the present way of the universe, not the universe, the solar system. The catastrophe theory, which is the theory that stuff smashed together and created the planets. You got planetesimals, which is just an idea, or not an idea, it's proven, but when the solar system was forming, stuff was colliding together. Planetesimals were the smallest ones, and then they became protoplanets, and then they became actual planets. So Pluto and Ceres are probably planetesimals that didn't have enough mass to form into proper planets. You got tidal theory and tidal heating, and protostars, which is the same as a protoplanet, just a star. Another part of the solar system, you have trans-Neptunian objects, or anything further out than Neptune, which includes the Kuiper Belt, which is mostly made up of comets and probably some asteroids as well. I'm not sure the percentage of each. I know there's a lot of comets though. And then I have this here, which is the Oort cloud, which is like everywhere around the solar system. It kind of encapsulates the whole thing, kind of like a Pokemon ball, I guess is a good way to put it. I have Pluto here, which is a dwarf planet. Around Neptune, I have atmosphere, which is just, there's a bunch of different layers to the atmosphere around planets, and that's what protects us from things like asteroids, and the magnetosphere protects us from the sun's radiation and whatnot. And, I have exoplanets, which are out beyond our solar system. Different kinds that we looked at over this unit were Jupiter-like, Neptune-like, water worlds, super Earths, and terrestrial worlds. And then there's chemical differentiation, which is just looking at a planet and being able to discern what makes up that planet and its atmosphere by looking at the light that comes from it. And other than that, there's the heliosphere, which is also, or the heliosphere and the sun's magnetic field, which kind of holds the whole solar system together. And I believe that is everything from this unit. Thank you for listening.